critical velocity and the terminal velocity. So now we will find that what is the difference between them. Are they equal or not? The critical velocity and terminal velocity are different. And are not same. It means that critical velocity is not equal to terminal velocity. Terminal velocity. So they are different. So now let us have the difference between them. This we have the line now here we will have this is now critical velocity. Here we will have the terminal velocity. Terminal velocity. Now number one. Critical velocity is minimum velocity, and here the terminal velocity is maximum velocity. Is maximum velocity. Now we can have the critical velocity Vc is equal to R eta upon Rd. This is the formula for critical velocity, where R Reynolds number, eta coefficient of viscosity, and this R radius of tube, and D the density of liquid. Now here the terminal velocity Vt is equal to 2y9 r square upon eta rho minus sigma into g. R the radius of the tube, that is the, but here this r is the radius of the spherical body, where r radius of spherical body. And eta is the coefficient of viscosity, that we are having the same one. This rho, the density, rho density of body, sigma density of liquid, and g the gravitational acceleration. Gravitational acceleration. So now these are dependent upon this one, and these are, this now the formula are quite different. Now third difference. The critical velocity, it is independent of gravity of Earth. So this Vc is proportional to g raised to power 0. And here it depends upon gravity of Earth. So this Vt is proportional to g. Here this is independent and this is depending upon this one. Now fourth. Now this critical velocity is independent of the density of the body. So here we are not having about the density. So this is now critical velocity is limiting velocity of the flow of liquid. Of the liquid. So if we have that and this terminal velocity is not limiting velocity. It is the maximum velocity. It is maximum velocity acquired by body falling vertically downward. Falling vertically downward. And this now let we have more better. Let V equal to mean velocity of liquid, then if this V is less than equal to Vc, the critical velocity, the flow is laminar, and if V is greater than Vc, the flow is turbulent. Flow is turbulent. So this decides that which kind of nature will be the flow, whether it's the streamline or laminar, or this will be the turbulent. So if the velocity of the liquid is more than the critical velocity, then flow becomes the turbulent. If the mean velocity of liquid is less than the critical velocity, then this is the flow is the laminar flow or the streamline flow. Now fifth, at critical velocity, the viscous force is dominant over inertial force. Inertial force. It means that the net force is not equal to 0. So net force, this is not equal to 0. In this case, now in case of terminal velocity, at terminal velocity, net force net force in the liquid, net force is not equal to 0. So here the net force on the body is equal to 0. So the terminal velocity is a constant velocity, and the body does not stop when the body has attained the terminal velocity. So this falls with a constant velocity. So the acceleration of the body is 0. So net force on the body is equal to 0. So these are some differences between the critical velocity and the terminal velocity, and you must understand that both are the different one. The critical velocity is related to the flow of the liquid, while terminal velocity is related to the velocity acquired by the body, which falls vertically downward or moves horizontally in the viscous medium. So thank you very much.